Hello and welcome to PDFsupply.com. Today we're going to be testing an IC695ALG600. This is an RX3i Universal analog input. And what I mean by that is that this particular card can test just about everything analog input. It will measure thermocouple inputs, all types, RTD inputs, resistance inputs, current from 0 to 20 milliamps, 4 to 20 milliamps, or negative to positive 20 milliamps, voltage, negative to positive 50 millivolts, or positive to negative 150 millivolts, 0 to 5 volts, 1 to 5 volts, 0 to 10 volts, and negative to positive 10 volts, all DC, of course. So this is capable of quite a bit. So the first thing I want to show you is physically what I have in front of you is the module powered up in a rack. I have a green light in the module OK, or you may have a blinking green light, which means it's prepared for configuration. So if you don't have a green light, if you don't have a blinking green light or no light at all, or it's red, that means that you won't be able to follow this test. It's a problemed card. It will need repair or replacement. Okay. The other thing, of course, is I'm using a 36-point high-density terminal strip, and when I push this lever into the uprightmost position, that means that the terminal block is completely fastened to the unit. It's making connection, and it's telling you that the field status in the terminal block should be green, meaning it's okay and it's ready for probing. The other thing is that you guys are, depending on what you're using this for, you may be only using it for one particular purpose, but in order to respond to all of you on how to test this, the things that I have in front of me to test it is a J-type thermocouple. I have a 150 ohm resistor, a 3-volt battery for my my positive and negative voltage DC probing, and I also have a 4 to 20 milliamp DC generator, output generator, so that I can probe these channels. Now, it's okay if you guys have different resistors or a different metal type thermocouple or a different way of getting your voltage to the channel, as long as it's within the parameters of number one, which you're using, and what the card is capable of. Okay. So the next thing that I wanted to mention, of course, is the wiring can be a bit confusing on this. And I'm referring to the manual, and I'm on page 5 right now, under the heading Module Wiring. And there's a matrix on the top portion of the page referencing the terminals and the different applications and what terminals those applications, once they've been configured properly, go to. So to make it simple, I'll just start with the fact that on the far left and right hand side of the page, you'll see it says terminal at the top heading, and then it has the numbers of the actual screws, terminal screws. The left side is 1 through 18, the right side is 19 through 36, just as it is on the actual physical terminal. What you need to know is on the left hand side is the positive inputs, 2, 4, 6, and 8. And on the right hand side is 1, 3, 5, and 7. Just pay close attention to exactly which terminals go to which application, okay, when you're probing. Then below that, there's also a matrix that shows thermocouple voltage, or a diagram rather, thermocouple voltage and current, the different wiring patterns that you want to use if you're using current or voltage or thermocouple. And on the right hand side is RTD, or resistance, where it gives you diagrams that you can fix either 2, 3, or 4 wire applications. Okay? So again, pay close attention to that. Next thing I'm going to do is go to my software. I'm in Proficy Machine Edition, and I've made a new blank file. So what I want to do is, if you don't already have it expanded, expand my rack. I happen to be using a CHS007 rack. You can follow this with a CHS012 or 016, as long as the module fits in it. And my first two slots are being used with the power supply. The second two are with the CPU, and that leaves me with slot number 4. Now you can either double click or right click and select Add Module, Analog Input tab, and again this is the RX3i Universal Analog ALG600. Alright, now the first thing that we want to do is go through our configurations. Starting with, we're on the settings bar. Just note that your reference address, the first channel that we'll be probing is analog input 00001. Alright. First channel is disabled. I'm going to start with voltage, or voltage or current. Now notice all the different applications that are here to start with. You go from having the circuit disabled to turning on either voltage or current or thermocouple or RTD or resistance. And then of course it gives us the default value is -10 to +10 volt DC, or you can switch it over to 4 to 20 milliamps and so on, millivolts. And I'm going to use 16-bit integer. Channel 2, do the same thing, 16-bit integer. And I'm just going to go through the first 4 channels with you guys. I encourage you to do all the channels, but this is just to give you an example of the -10 to +10 volt DC and how to configure it. So the scaling isn't particularly large. It's just a figure of -10 to +10, just like the voltage itself. So when I'm probing this with a 3-volt battery, I expect it to basically just say 3, +3. Alright, and I'll show you exactly what that looks like in a moment. So the next thing is, now that I have a configuration that's worthwhile of probing the card, I'm going to connect up to the processor hitting this lightning bolt icon. And then once we're actually connected, you hit the green handprint with toggle online mode. Now pay attention down below. We're in programmer mode. The processor is stopped, the run mode has been stopped, the outputs are disabled, and the configuration is not equal. And what that's telling you is that the processor was handling something different before you've asked it to test this ALG600. So, in that case, we're going to go to Target, Online Commands, Clear, Controller, and I/O Fault Table. We're going to clear those faults, just those two, bottom 2 selections. And that'll keep us from getting hung up when we do the download and run. It's keep it from getting confused. So we hit download and run active target. The first thing it's going to ask us is what exactly do we want to download to the processor. And in this case, again, this is just a simple test of the inputs. We're going to do hardware configuration in motion and logic. The download takes a couple minutes. Once it's done, we'll go ahead and open up our analog input table. I'll show you guys where to find that and where we're going to look for the inputs or the values. Another thing that I wanted to mention that if I didn't mention it before, there's on terminals number 1 and 2 and 35 and 36 are CJC1 and CJC2 for the terminal 35 and 36 on opposite sides of the terminal. These are the cold junction compensators. They're used optionally, not mandatorily, but optionally when you're measuring with thermocouple. Okay, so if that's an application, if you're using a thermocouple and you need a reference junction as part of the application, please keep that in mind, that that's where those cold junction compensators get connected. All right, for this test I will not be using those, but it may be something that you need to look into to make sure whether you're supposed to be using it or not. Now, if we expand on the default tables, you have analog input. All right, and that's where we're going to start seeing our values. We're going to start with analog input address 00001, and then 3, which is channel 2, 5, which is channel 3, and 7, which is channel 4. Okay. Pay close attention to the wiring scheme that's again on page 5 of your manual. Channel 1 for voltage is positive on 20, negative on 22. Okay, and then there's my positive 3 that I was explaining before. Alright, it starts with full scale. It's at negative 11. Should actually be a positive 3, and we have positive 3. And then channel 2, when it comes to voltage or current, again is going to be on the left hand side of the strip with all the other even numbers. However, it's not directly across, it's down a little bit. So it's terminals number 4 and 6. Okay, again, I have positive 3. I'm able to stimulate the circuit. I'm able to get an accurate reading, and I'm getting a reading that's stable. Again, those 3 things, no matter what it is you're testing, you have to have those 3 things. An active channel, an accurate channel, and a channel that's not fluctuating. Those 3 things are very important. Channel 3, 24 and 26, positive on 24, negative on 26. Positive 3 volts. Channel 4 is in the middle of the matrix, and we want terminal number 8 and 10, positive on 8, negative on 10. Okay, positive 3. Okay, so let's stop the controller for a moment. Go back to our ALG600. For those of you who are testing milliamps, all right, I have a 4 to 20 milliamp generator. We're going to select that. I'm going to keep my integer the same, 16-bit, and I'm just going to change over from voltage to milliamp DC. First 4 channels, just to keep this a little quicker. Again, I encourage you to test all 8 channels, make sure they're all working properly. Go to target. Please note, my configuration is no longer equal. That's because we've asked it to switch from voltage to milliamp. So we go to our online commands, clear, and clear those 2 faults. Bottom 2 selections is controller fault table and IO fault table. Okay, yes. And let's re-download. We're downloading the 4 to 20 milliamps DC. Here's where I'm going to be using my generator. The same as before, when it asks us what we want to download, is simply the top 2 selections, configuration, motion, and logic. Select OK. Now another thing is while this is downloading, please familiarize yourself with the wiring diagram. This is where it becomes confusing again. We're no longer using, for example, channel 1 is positive on 20, negative on 22. We're going to be using the middle portion of those 3 screws. So our positive will now, upper middle, we're going to be, positive will be on the 20 and the negative will be on 21. Alright, that's the in and the return. Same thing goes for all the other channels that you're going to be testing. It's the top 2 screws. And it also tells you that on the bottom left hand side, if you look under thermocouple voltage or current measurements, it tells you for current you want to use the top 2 of the 3 screws for your measurement. Alright. Select OK, go back to our analog input table. And I've got my milliamp generator powered up. Positive on 20, negative on 21. Okay, I beg your pardon. It's positive on 21, negative on 22. Channel 2 will be positive on 5, negative on 6. That might be difficult to reach. I'm going to have a devil of a time getting that on there. Hopefully you guys have long probes. Okay, I'm getting the same reading. Okay, same thing here. As I mentioned before, when you're probing these channels, make sure that each channel gives you the same reading if you're giving it the same value. So that would be the accuracy part. Make sure that the channel's actually giving you a value, and make sure that the value is stable. Okay, in any order, those are all very important. It doesn't really matter which order. Okay, the next thing is I've tested the first 2 channels. We're going to test 3, which is 25 and 26. Okay. Channel 4, which is 9 and 10. Okay, so that's perfect. Okay, the next thing we're going to do is stop the controller. Go back to our analog card. And we're going to choose Thermocouple. As I mentioned before, I'm using a J-type Thermocouple. Celsius or Fahrenheit, whichever you guys, whatever application that you guys happen to be using. I'm going to leave it as Celsius just as because I'm just probing the channel to make sure it's working. But if you're using Fahrenheit, then you may want to do that. All 4 channels, switch over to Thermocouple. Again, I'm using J-type. Alright, and I have my scaling here. And same process as before. We're not equal anymore. We're disabled. We're going to go to Target, Online Commands, Clear, All Memory. Oh, pardon me. Selected. Bottom 2 selections, Controller and I/O fault table. What I meant to say is not all memory. And download and run. Okay, here's a situation where if you do need a cold junction compensator for your particular application, that you'd want to have it. And then, again, cold junction compensator number 1 goes into terminals 1 and 2, and cold junction compensator number 2 goes in terminals 35 and 36. So cold junction compensator number 1 serves channels 2 through 8, and the cold junction compensator number 2 serves channels 1, 3, 5, and 7. So works for both sides of the terminal strips depending on the odd and even numbers. Same thing as before. When it asks you what you want to download, it's just the top 2 selections, configuration and motion and logic. Again, there's no reason for me to write anything to permanent flash memory for a simple probing test. Okay, outputs are now enabled. Analog input table. But if you're just watching this for this one particular one, and the analog input table is located under default tables. Now, Thermocouple falls under the same as voltage and current terminals. Okay, so we're going to go ahead and probe those terminals. I have my positive on 20 and my negative on 22, and I immediately have a range of somewhere between 26 and 28. Okay, that will eventually steady itself. Channel 2 is 4 and 6. Notice my range is almost exactly the same. It's between 27 and 28. Okay. Now, fluctuation that I'd be concerned with is if it was massively fluctuating. You know, going. So my numbers are 27, 28. That's about right. Maybe it's 27 and a half. But if it was fluctuating between 20 and 35, and it was kind of going crazy, then I would be very concerned about the channel. But this looks very good. Each channel is giving me about the same answer. Channel 3, 24 and 26. 24 positive, 26 negative. Again, I have a same reading as we're seeing with the other channels. And channel number 4, 8 and 10. Same reading. Extremely minor fluctuation, but it looks okay. So that's what you want to see with the thermocouple. Same as all the other ones. Number 1, the channel needs to give you a reading. Number 2, the readings should be the same if all the scaling is the same. And number 3 would be that it's not tremendously fluctuating. Another thing that applies to the thermocouple itself is if you guys have a thermocouple where you can apply heat to it, you know, maybe have a hairdryer or a heat gun to warm up the metal, the conductor. You know, my J-type, I could run a heat gun across it to make sure that the value goes up. And of course, if it's a safe environment for the conductor itself, or it's wrapped in something, you can always dip it in ice water to see that it goes down. And what you're doing there is testing the range and resolution of those channels. Okay, last thing. We're going to stop the controller one more time, and we're going to take these circuits and switch them to RTD. Alright, so okay, I have a 100 ohm, so that'll actually work perfectly. When we're going to do a 2-wire wiring diagram. Now you guys are welcome to do a 3-wire if you want. There's information again on page 5 of the manual on how to do a 3-wire if you choose to do that, or if that's your application. Okay, so again, change to RTD. I have 100 ohms. Use whatever ohms that you guys have, 200, 500, 1000, the different metal types. Alright, there's all sorts of choices there. Celsius for my particular test is fine, 2-wire. Again, RTD, 100 ohms, perfect. And RTD, okay. Same thing. The controller in the software never forgets, it's not equal anymore. Go to Target, Online Commands, Clear. We're going to clear the bottom 2 selections, Controller and I/O Fault Table. Yes. And then download and run. Got to make sure that you do that step and clear those faults, otherwise you are going to get hung up during the download process for sure. When it asks us what we want to download, same as the other tests, configuration, motion, and logic. That'll be the top 2 selections. So now's the time to make sure that you familiarize yourself again with this wiring diagram. We're using RTD, so this is on a different side of the matrix. All right, look at your channels that are under RTD or resistance, and then also take a look at the bottom right-hand side of the page where it suggests your 2-wiring wire probe, or 3-wire if you guys are using 3-wire, and make sure you know what you're doing there. That way when we touch these we get accurate readings and you don't falsely think that there's something wrong with the card. Again, this card is capable of an awful lot, so there's a lot of testing to do in my particular case, but in your case you may only be using the card for 1 or 2 purposes. So okay, so we're going to select OK. Hopefully you guys are in run mode like I am. Your status bar at the bottom should read the same as mine. If it doesn't, take a look at your feedback zone. It'll tell you why it's not, if it isn't, and or you can go to Target, diagnostics, and it'll give you any faults if there is any. Okay, I'm not faulted. And then of course, if you're still not in run mode and everything's perfect, then just check underneath your battery door, make sure that the switch in the upper position, the upper switch is in the far right position, enabling the outputs. So terminals number 19 and 20 are our excitation and input for the resistor. That's channel 1. Okay. Channel 2 would be terminals number 1 and 2. And so forth. So you guys want to check all your channels, check all 8 channels. I only do 4 channels to begin with, so that to make enough time for you guys to understand how to configure each channel. Now, just as a quick recap, the module itself should have a green light or a blinking green light during power up. If there's no light, then that means it needs repair or possibly replacement. The other things are to test each channel depending on what your application is to the best of your ability, using the matrix and using the different input types that there is available to see if it's a good working card. If you do not have a stable channel or channels, or if the channels aren't working at all, or of course if the channels are not giving an accurate reading or a consistent reading, then that would mean that there's something catastrophically wrong with the analog card and it would need repair or replacement. Okay, the ALG600, IC695 ALG600 is something that we do commonly repair here at PDF Supply. We offer exchange programs, new and remanufactured products, and same-day shipping. So if that's something that you need or interests you, please see us at pdfsupply.com. Thank you.